Hello, grade 8 students. In this video, we're going to start with a new lesson, which is about parallelogram. We're going to revise together what's a parallelogram, what are the properties of a parallelogram, and how we can prove that this quadrilateral is a parallelogram. So our objective is to identify and use the properties of the parallelogram. Let us first of all remember together what's the meaning of a parallelogram. So a parallelogram, it's a quadrilateral. Quadrilateral means it has four sides and four angles. So the parallelogram is a quadrilateral. It's a special quadrilateral because it has one important or one property which is special, which is the opposite sides are parallel. So the properties of a parallelogram: in a parallelogram, you can find that we have the opposite sides are equal or congruent. And as you can see here, we have a parallelogram ABCD. Look at the naming very well. So we name clockwise, like the arms of the clock to the right side. That's how we name a parallelogram, clockwise, ABCD. What are the opposite sides that are equal? AB is equal to DC and BC is equal to AD. The second property is that the opposite sides or the opposite angles, are equal. So if you look at the figure, the angle DAB, it's opposite to the angle DCB, so they are equal. And the angle ADC, it's opposite to the angle ABC, and they are equal. The third property in a parallelogram is that the diagonals bisect each other. What's the meaning of the word bisect each other? Means that they intersect at their midpoints. So the midpoint of the diagonals are the same. If you look at the figure, O, it's the midpoint of the diagonal BD, and O, it's also the midpoint of the diagonal AC. So if two lines, they share the same midpoint, we say that those diagonals bisect each other. So OA equals OC equals, because they have the same midpoint, and O, it's also the midpoint of DB, so OB equals OD. So that's everything about parallelogram till now, that the opposite sides are equal and parallel, the opposite angles are equal, and the diagonals bisect each other. The sum of any consecutive angles is 180. What I'm trying to say that, just a second, that this angle and this angle, their sum is 180. So suppose, for example, that this angle here is 70, then this angle is 110. Why? Because their sum is 180. Also, this angle with this angle is 180. So this is 110, and that's what makes opposite angles are equal. So the last thing we're going to talk about is that the parallelogram admits the intersecting point of its diagonal as a center of symmetry. So this point, it's the center of symmetry of the parallelogram. What I'm trying to say is OA equals OC equals OF equals OI. So any line that you draw, it's the center of symmetry of this parallelogram. So let us make a revision. So in order to tell that this quadrilateral is a parallelogram, so if suppose I gave you a question and I asked you to prove that this quadrilateral is parallelogram, what you're going to prove is either the opposite sides are parallel or the opposite sides are congruent. The two opposite sides are parallel and congruent. The opposite angles are equal, or the diagonals bisect each other. So only one of these conditions should be verified. So if you have, for example, the diagonals bisect each other, then you say definitely that this is a parallelogram. If you tell me that the opposite sides are parallel, so definitely, so what I'm trying to say, if you have here, let me just draw, okay, if you just prove for me that this side is parallel to this side and this side is parallel to this side, that's enough to tell that this quadrilateral is a parallelogram. So let us solve some exercises to know how you are going to think, how you are going to write, and all these details. So let us start by the first question. In this question, you have two parallelograms, ABCD and CDEF. So they are given that both of them are parallelograms. So I always advise you, to put the coded figure. So AB is equal to CD, and CD is equal to EF because the opposite sides are equal and parallel in the parallelogram. Also, this side is equal to this side, and this side is equal to this side. Okay, because also they are opposite sides of a parallelogram. Even the parallel, so you can tell that AB and DC are parallel, or DC and EF are parallel. Now you are asked to prove that ABEF is a parallelogram. So, as I told you before, to think of proving a parallelogram, you have to think of one of the properties that you have learned. So either you're going to tell me that the opposite sides are parallel, or the opposite sides are equal, or one pair of opposite sides are equal and parallel, or the diagonals bisect each other. Let me first join the parallelogram we are going to prove. So it's ABEF or ABFE, sorry. So you are asked to prove this quadrilateral parallelogram. Of course, it's not about diagonals, as you can see. So we're going to talk about sides. So AB, it's parallel to DC, and DC, it's parallel to EF. Then AB and EF are parallel, because if I have two parallel lines, the parallel to the first is parallel to the second. And AB, it's equal to DC, DC, it's equal to EF. So AB and EF are equal. So look, how do we write? Since ABCD is a parallelogram, then AB, it's parallel to DC, and AB, it's equal to DC. Since CDEF, it's a parallelogram which is given, DC and EF are parallel, and DC and EF are equal. So AB, it's a parallel to EF, and AB is equal to EF. Then this is this quadrilateral is a parallelogram having two of its opposite sides parallel and equal. Let us now do another exercise. We have as a given MO and T, a parallelogram. So this is a parallelogram, MO and T. A is the midpoint of AN. So we are asked to draw A, which is the midpoint of AN. So directly you can put this coded figure because it makes things clear for you. Now you are asked to draw the point I, or to plot the point I, which is the symmetric of M with respect to A. Every time you see this word with respect to A, then A, it's a midpoint. This is a rule. Midpoint of what? Of IM. So you join IM, A, it's a midpoint of MI. So MA equals AI. So that's how you draw it with a ruler. And A, it's also a midpoint of MI. So you put the coded figure as you can see. Now, you have to prove that MOIN is a parallelogram. Remembering together the properties, the opposite sides are equal and parallel, the opposite sides are equal, the opposite sides are parallel, or the diagonals bisect each other. So it's obvious that we're going to talk about the diagonals. Why? Because A is the midpoint of ON, this is given, and A is the midpoint of MI, so they share the same midpoint. So definitely MOIN is a parallelogram. So that's how we write. A is midpoint of ON, A is midpoint of MI, then MOIN is a parallelogram because the diagonals bisect each other. Okay? Now you have to prove that T and I are collinear. To prove collinear, you have two ways. Either you tell that the angle is straight, 180, which is not the case in our exercise. Another way to prove that 3 points are collinear, look how easy this is. I'm going to make a revision, then we're going to apply in our exercise. If you have two parallel lines, suppose that these are AB and CD. It's given that AB and CD are parallel. Also, it's given that AB and DM is parallel. So CD and DM, they share a point in common. So definitely they are going to be collinear, CD and M, because both of them are parallel to AB and they share a point in common. So to apply this in our lesson, you know that MO and TN are parallel because it's given that MO and T is a parallelogram. And now we can tell that MO and NI are also parallel because we have proved that MOIN is a parallelogram. And they share a point in common, which is N, then definitely T and I are collinear. Not only collinear, it's also the midpoint of TI. So I wish you got the idea. So every time you have an exercise and you need to prove a parallelogram, you have to go to the properties and prove one of them.